안녕하세요. That's the extent of my Korean, so I apologize. My name is Bob Zollo, and I'm the product planner for many of the power products from Keysight's Power and Energy Division. What I'd like to speak with you about today is a very important subject around enabling efficient energy usage. And today we're going to talk about the new IntegraVision Power Analyzer. But before I go into detail on this new product, I would also like to cover briefly some other solutions that we have helping customers in this important area around energy efficiency. So energy efficiency and efficient use of energy is key in today's world. We're running short on energy. In order to overcome the energy shortage, we must use the limited energy that we have more efficiently. In order to make better use of new energy sources, such as wind and solar, we need to make those cost-effective and use them more efficiently. So Keysight is very committed to this. As you heard earlier, we have reorganized in such a way that we have an organization focused on energy, and I am part of that organization. In fact, I've spent the last 30 years in the areas of power and energy. So let me begin by pointing out that energy technology really touches many different parts of our lives. When we think about energy, often we think about the generation side of energy. And in energy generation, we're talking about converting one energy form to another. It could be converting solar energy to electrical energy to power your home. It could be converting wind energy to supply the grid with more electricity. Or it could be UPSs or satellites or even other electronics that are used to create energy from one format to another. And in order to generate that efficiently, they need tools to help that. The engineers do, and that's where Keysight comes in. But once the energy is generated, we have a challenge with storing that energy, especially when it comes to wind and solar, because these are not constant. The wind isn't always blowing, the sun isn't always shining. Therefore, if we're going to make maximum use of wind and solar, we're going to need a way to store that energy. Generally, the energy is stored in batteries, but today battery technology is limited for storing large amounts of energy like you would need to back up the grid. But in addition to battery storage, there's other related technologies. There's battery management systems and something called home energy management systems. A home energy management system is like having a battery backup for your entire home. It takes energy from solar, it may take energy from wind, it takes energy from the grid. If you have excess energy, it stores it in a battery, and then if you're short on energy, it can release that energy from the battery to power the home. So it makes a very efficient use of that. But in order to develop these technologies, engineers need tools to help them in the area of efficient use of battery storage, and that's where Keysight products come into play. An important point I want to make, though, is around transportation and electric vehicles and hybrid electric vehicles. This actually brings together both of these technologies. The cars, of course, have large batteries on board to store the energy, but there's also generation technologies. The energy in the battery needs to be converted from DC to AC to power the battery's motors, the car's motors, excuse me. It also has to be able to recover power from regenerative braking. So an electric vehicle is an example of power generation technology combined with power storage technology. And of course, electric vehicles is an important emerging technology in today's world. So, energy efficiency is very important to make best use of these technologies. And Keysight is focused on delivering solutions to help engineers make more efficient use of the energy. In the area of generation, an example I'm going to briefly touch on is a photovoltaic simulator. This is used to simulate solar panels to help engineers who are developing inverters, to develop those inverters more efficiently. I'm going to share an example in storage technologies around a battery simulator, again, to help engineers who are building conversion technology to make better use of the batteries. But most importantly, I'm going to talk about the power analyzer, which really cuts across all of these different areas, because if you're simulating generation and you're simulating storage, at some point you need to measure the efficiency, and that's where the power analyzer comes in. So let me begin with briefly touching on a product called the N8900 photovoltaic PV simulator. The N8900 photovoltaic simulator is designed for simulating high voltage strings. This is when you take solar panels and you put many of them together into what's called a string, and you create a high voltage string. High voltage strings use energy more efficiently and use the investment in solar more efficiently. Therefore, this new photovoltaic simulator allows engineers to simulate those strings and therefore make a better product. That product being a AC to DC to AC inverter. The N8900 is the only photovoltaic simulator that can provide 1500 volts. It's quite small, as you can see here. This is 15 kilowatts in a package about this big, and they can be put in parallel to go up to 90 kilowatts. So this is for medium-sized solar installations. Thanks to this new product, engineers can rapidly and repeatedly create all the necessary test conditions that they need to simulate all of the different solar conditions that are necessary when testing their inverters. Next slide. The next quick example I'd like to show is with respect to storage technologies. That is a battery simulator based on our advanced power system. In this case, the battery simulator is based on our APS, Advanced Power System. And we have several different models in our family. There's a 1 kilowatt version and a 2 kilowatt version, and these can be put in parallel to make larger, higher powered systems to simulate larger batteries. The key advantage of the APS in this battery simulating application is that it can actually act like a real battery from the standpoint that batteries have to both source energy and absorb energy. They source energy when they're discharging, they absorb energy when they're recharging. So by creating a battery simulator for engineers, these engineers can build better charging and discharging systems. They can build better algorithms for doing battery charging, and therefore get more energy out of the battery. More energy out of the battery means the car, if it's an electric vehicle, can drive further before having to recharge. It could mean that your battery backup lasts longer on your home, or it could mean even that your cell phone lasts longer if they're smaller batteries. So there's a great advantage to having a battery simulator to increase the storage capacity of the batteries. Next slide. So here we are now on the main subject, which is our new power analyzer, the PA2203. It's a IntegraVision, we call it, power analyzer. And what's new about the IntegraVision power analyzer, this one, is this is our 4-channel analyzer suitable for 3-phase AC applications. Next slide. So the IntegraVision power analyzer family enables engineers to make the measurements they need to understand what's happening inside their devices, to validate, make accurate measurements, and therefore improve their design. The new power analyzer is 4 channels, which makes it more versatile than the previous model, which was only 2 channels, and it's suitable for 3-phase measurements and analysis because it has 4 channels. So what is a power analyzer? How did we come up with this concept? Well, power analyzers actually have been around for many years. And they're quite useful to engineers who are trying to understand the quality of the electricity that they're using or that they're generating in the case of an electrical generation system. But one of the challenges engineers have had with existing power analyzers is that they're very difficult to use, and therefore they're unsure if they're making the right measurement. So when we set out to make a better power analyzer, we thought, how can we make a power analyzer better? Well, if the issue was ease of use, we thought, how could we make an easier one? We thought that the easiest instrument for any engineer to use is an oscilloscope. Every engineer has an oscilloscope on his bench. So we said, why don't we make a power analyzer that feels like an oscilloscope? So we took the measurement engine of a power analyzer, combined it with the user experience of an oscilloscope, and created the IntegraVision power analyzer. So that means, like a power analyzer, it is very high accuracy. It has 16-bit resolution. It has 1,000-volt isolation. That means you can plug it directly into the AC line and measure the AC line without the need for special probes. And it can measure current directly, whereas an oscilloscope would need current probes. So that's the power analyzer engine, the inside. The heart is like a power analyzer. But what we did to make the user experience like an oscilloscope is it could measure and visualize repetitive waveforms. So when you look at this box, you say, this looks just like an oscilloscope, because the face is the face of an oscilloscope. So it can show repetitive waveforms on the screen. It can also make single-shot measurements, which is very important. The ability to look at a single event, and I'll give you an example of that in a few moments. It can display the waveforms in real time, so these will update as the signals change. Human beings are very visual. We like to see things. Seeing is believing, we say. So the idea of seeing those waveforms really helps the engineer to understand what's happening. That's why we call the product Integra Vision, to see what's happening. And of course, it also has a large touchscreen. Everyone feels that touchscreens make the user experience easier, and we certainly have that kind of user interface. So, the Keysight Integra Vision Power Analyzer is a single instrument that allows engineers to see what's happening because they can see the waveforms, to measure what's happening, and that's this blue box here gives them all the measurements on their AC power, now for three-phase, and therefore to prove the performance of their designs. It's a highly accurate family of instruments with 0.05% basic accuracy and 16-bit resolution. If we compare that to an oscilloscope would have about 1% accuracy and 8 to 12 bits of resolution. So we're talking about something that's about 100 times more accurate than an oscilloscope for making these kinds of measurements. It allows the engineers to visualize transient and inrush and state changes with a high-speed digitizer of 5 megasamples per second. And it allows engineers to view things in real time or in the frequency domain when they want to look at harmonic content of the AC signal. And that's important when you're concerned about the quality of the power that you're generating. It has a 300 millimeter touchscreen, as well as USB on the front for storing information. Next. So the new version, the PA2203, is designed for R&D engineers who are building electronic power conversion systems. What we mean are AC to DC power supplies, like you would have to charge up your computer, that plugs into the wall AC and puts out DC to charge the laptop. A DC to DC converter. This would be useful in a car, where the car battery could be 120 volts, but many of the subsystems within a car run on 12 volts. So there would be a 120 volt to 12 volt DC to DC converter. Or it could be used for DC to AC inverters. In this case, there's a picture of one here. This is a solar inverter that takes DC power from solar panels and converts it to AC power to run a home or a small business. So we call that a DC-AC inverter. This box here is probably about this big and sits on the side of a building and produces probably about 15 kilowatts of power. So the key applications for a three-phase power analyzer is for testing grid-connected devices like inverters and power distribution units. It can analyze three-phase motors like you would find in an electric vehicle. Other high-power devices, aircraft and satellite power systems are all run off of AC. Lighting systems, electronic ballast. These lights, I can see, for example, are LED lights. LEDs are run off of DC power, but the energy coming to them is AC, just like you would have in any other building. So there's a small AC to DC converter in each of these lighting systems. And of course, battery chargers, electric vehicles, and hybrid electric vehicles are all examples of high-power three-phase AC. These engineers who are designing these systems need to make power and efficiency measurements on their devices in order to determine if they're making improvements and using energy more efficiently. The IntegraVision Power Analyzer family is the world's first power analyzer with a touch-driven oscilloscope visualization capability. So what do I mean by that? Well, I'd like to give you an example of how this is important for an engineer. So let's use an example. In this example, I'm looking at how a pump, a water pump, to pump out a basement to keep it from flooding. Like you have a bilge pump in a boat, well this would be on a house, okay? And I have one of these in my house, by the way, okay? So it's a pump that pumps out water so your basement doesn't flood. And the question is, could this pump run off of a battery backup? So if the power goes away, can I continue to use the pump? And that's important, of course, because you don't want your basement to flood. So the questions to ask would be, can this pump run from a UPS uninterruptible power supply? Battery backup like you'd have on a computer. Pumps, when they first start up, tend to have a large surge of current. Will that current damage the UPS? That's another question that needs to be answered. And last question is, how long will the pump run before the battery is depleted? Because what's the point of having a battery backup on the pump if it doesn't last? So with the IntegraVision Power Analyzer, with oscilloscope visualization capability, we can very quickly and very easily answer these three questions. So the first question is, will the startup current overload the UPS? Well, this is a screenshot from the IntegraVision Power Analyzer, like you see over there. The top waveform is the AC voltage. The bottom waveform is the AC current going into the pump. You'll notice the pump has no current flowing into it here, and then the pump turns on. And you see there's a cycle here, a peak current. This is about 41 amps. And then it quickly settles down to about 20 amps. So with this single-shot visualization capability, I can quickly look and go, no problem. It won't overload the pump because the surge current is not so high. The only way I could have seen that is with a single-shot measurement capability. Other power analyzers on the market can't show you this picture to an engineer who's trying to answer these questions. The next picture here answers the question, will it run off of a UPS? So we could make very accurate power measurements here of how much power is being consumed by the pump. And I can tell from these measurements that the size of the UPS is suitable to run the pump. At the same time as seeing these measurements, I can actually look at the waveforms of the voltage going into the pump, the current going into the pump, and the power going into the pump. And again, I can feel confident that these numbers are correct because I see the waveforms, and the waveforms look correct. So seeing the waveforms and seeing the numbers gives me high confidence that I'm making the right measurement. And then lastly, I can observe the total amount of energy that's being consumed. So what this waveform here is, this bright color, is the current going into the pump is off, then the pump comes on, there's that same peak current as here, and it runs for 6 seconds and then shuts off. So every time the pump comes on, it runs for 6 seconds and shuts off. Now I could measure the total energy consumed over here on the power analysis panel. That tells me how much each time the pump comes on, how much energy it consumes. Therefore, I can calculate how many times the pump will run before the UPS runs out of power. So I can quickly answer all three of these questions because I have a power analyzer that gives me single-shot measurement capability, visualization, confidence, accurate measurements, and the ability to do integrated energy calculations in a single instrument. If I just used an oscilloscope, I could make this measurement, but I couldn't make this measurement or this measurement. If I just used a power analyzer, I could make this measurement, but I couldn't make these two. So by combining and creating the world's first visualized power analyzer, I could make these measurements easy, and that's what our engineers are looking for. An easy way to make measurements to understand power consumption so they can improve their designs. So this is a picture of the rear panel of that power analyzer right there, the PA2203. I just want to point out a couple of things that are very important about this instrument. Each channel, you can see they're color-coded, yellow, green, blue, magenta, and the waveforms on the front panel of the instrument are also color-coded, so I know where the connections are, and I know what the waveforms that result from those connections. I can measure voltage on every channel. That's what these connectors are for measuring voltage. I can also measure current on every channel. So a 4-channel analyzer is like having an 8-channel oscilloscope, because it gives you voltage and current per channel. This connection right here is for a clamp-on current probe. Sometimes it's easy to make a current measurement by, if this is the wire, by clamping around the wire. And the clamp will tell you how much current is flowing through the wire. Or I can slide this little door and it exposes this green connector, and now this is like an ammeter that you'd find on a voltmeter, on a DMM I mean, and that means you can run the wire in and out of this connection, and it has an internal current measurement system, which is extremely accurate. So this is for ease of connection, and this is for highly accurate current measurements. It also has a trigger input and a trigger output. You don't normally find those on a power analyzer, but because we have single-shot measurement capability, having a trigger signal is an important feature to have. And it can be controlled over USB or LAN for remote control. And in fact, when we do a demo in a few moments, we'll actually be controlling the power analyzer using LAN capability. So the IntegraVision power analyzer is to visualize measurements, but we've actually taken it a step further with our new PA2203. So this is designed for 3-phase power measurements. Now, I'm an electrical engineer. I sometimes do some home repair and some wiring on my home. So touching AC power, safely of course, is not so frightening to me. But you can imagine when you have high power 3-phase AC, you want to make sure that you're wired up correctly so you don't damage the electronics, you don't damage your instrument, and you don't damage yourself. So what we've done is we've created an innovative wizard to visually configure and check the wiring. So this diagram here is a real-time display of how your instrument is connected. You can select whether you're going to measure single-phase or 3-phase, and for the 3-phase there are different configurations. You select the configuration that is your wiring system, and this screen will change and show you exactly how to make each connection for your particular configuration. Therefore, it's just follow the instructions. Tell it what you want, it will tell you how to wire it up. It gives polarity of signals, it tells you where to make the connections from the power system to your device that you're trying to measure. So this is an easy way to help customers, to help engineers ensure that they're correctly connected. Next slide. Now, once you're correctly connected, the next thing that you want to do is verify that you're connected correctly. So this diagram is called a phasor diagram. That's what they call it in the industry. And it's a polar plot that shows the relationship between the 3 phases of the AC power. Hence why we call it a phasor diagram. It shows phase relationships. So the 3 phases are typically what we say at 0 degrees, phase 1, then at 120 degrees, phase 2, and then at 240 degrees, phase 3. So each phase is 120 degrees apart. The lines represent the voltage and current on each phase. If you are connected correctly, these lines will line up with the 3 phases. If you're not connected correctly, one of these lines will be somewhere else on the chart. So it very quickly verifies that you followed the instructions from the previous graphic to this one before you begin making measurements. Once you've configured it properly, once you're certain that it's correct, now you can go ahead and make measurements and be confident that you're making the correct measurements in a safe way. So here we are now ready to make measurements. You'll see the waveforms, you'll see the tabular information. So if you're looking here and you say, one of these numbers doesn't look right, you can look back at the waveform and go, oh, I see the problem. Again, visualizing it. IntegraVision to visualize. It can also show a graphical display of the frequency spectrum. Okay, so here we are. I think we're ready to give a brief demonstration of how this might work. So what you're seeing now is the screen of the IntegraVision Power Analyzer. This screen is the same as this one. We are connected through a LAN cable between the PC and the instrument. What you're actually looking at is a page that is via Internet Explorer. So you bring up Internet Explorer, you type in the address, the web address of the instrument, and this page appears. So it's very easy to set up and measure using the LAN and the web browser. So let me explain what you're looking at. This portion here is a live updating information of the waveforms, and this portion here is the power quality measurements. Now, if you look, you can see the dots are changing. This is updating data, but like with any oscilloscope, I could grab the time base knob and make changes in real time as far as the time base is concerned, or if I want to change the amplitude on one of the signals, I can do this as well. So from this standpoint, this portion of the screen behaves exactly the same way as an oscilloscope. Now, in this case, we're looking at 3 channels: the yellow channel, the green channel, and the blue channel. And these represent the 3 AC phases. So we have phase 1 in yellow. This is the voltage on phase 1. Yellow here is the current on phase 1. And then the yellow down here is the power on phase 1. Similarly, the green, voltage, current, power, and the blue, voltage, current, power. And you can see these sine waves are out of phase by 120 degrees, and that's the way you would expect a 3-phase power system to work. So when I look at this, I can very quickly say, yes, this looks correct. Now let me make measurements. The power quality panel here in blue gives the very accurate measurements of what's going on here. We can measure the voltage on the group, measure the current, measure the total power, look at watts and VA and VAR. Those are the 3 types of power: real power, apparent power, and reactive power, and also the frequency, which is 60 hertz in this simulated data. This is simulated data. I'm not actually connected to 3-phase power. It's part of a demonstration. Okay, so this is the basic screen. What I did want to show you was that wizard. So if I punch the wiring button here, what it brings up is the picture associated with the wiring of this setup. So here we are. These are the 3 phases, and it's set up as a 3-phase, what's called Y configuration, because it's shaped like a Y. And then it tells you for each of the channels exactly how to hook it up. Now, channel 4 is not connected to anything right now, so it doesn't matter how channel 4 is connected. But you can see it shows channel 1 how to measure the voltage, also how to measure the current on channel 1, similarly channel 2 and channel 3. When you connect them in this way, you will get the correct measurements. To verify that, I hit the phasor button, and up comes the phasor diagram. And this tells me, as you can see, at 0 degrees, channel 1, yes, those look correct. At 120 degrees, channel 2, there's the voltage and current for channel 2, or the second phase. And at another 120 degrees, or 240, the voltage and current on that channel as well. So now I could look at this very rapidly and go, everything looks good. That means that the measurements I'm going to make here, that these measurements on the screen are correct, and I have good measurement quality for my AC signals. So 2 more slides to quickly summarize. So today we shared with you the new product, the PA2203. This is a 4-channel, 3-phase product. We're actually accepting orders on this right now, so this is not a future product, it's a real product, really on the market today. It was launched this week. Our first shipments will be in January, so we're about 3 months away from shipments, and you can see the US price. If we compare this to the previous version, the PA2201, that's a 2-channel product, whereas this is 4 channels. This is suitable for 1-phase, this one's suitable for 3-phase AC power. This came out last year, it's been shipping now for a few months, and the customers who have this product are very happy with it, and they're looking forward to having a 4-channel version, which is why we're launching this product. So to summarize and wrap up, Keysight Technology is focused on developing solutions to make engineers able to make more accurate measurements of their efficiency and therefore use energy more efficiently in their designs. Our PV simulators will allow engineers to use solar and create higher efficiency converters. Our battery simulators will allow engineers to increase energy storage capacity, and our new power analyzers will allow engineers to prove that they've made the efficiencies in their design. Thank you.